Welcome. In this video, we are going to go over a classic application of the cross product, and that is torque. So a bolt is tightened by applying a force of 5 newtons to a 10-centimeter wrench. The angle between the wrench and the force is 30 degrees. Find the magnitude of the torque about the center of the bolt, rounding to 2 decimal places. Okay, well, recall torque is just given by this cross product. And now when we want to know the amount of torque, we need the magnitude of torque. So that's the magnitude of this cross product here. So really we just need the length of the wrench times the force applied times the sine of the angle between these two vectors. All right, so the magnitude of the torque in this case is equal to the length of the wrench, which is 10 centimeters, so 0.1 meters, times the force here, the magnitude of the force, which is 5 newtons. We end up, oh, excuse me, I forgot one thing. The sine between these, so the sine of 30 degrees. So 0.1 times 5, that's just 0.5, so 1/2, times the sine of 30 degrees, which is also 1/2. And we end up with 0.25 Newton meters, which is joules. Now, there's a follow-up question here. Is more or less torque produced if the angle between the force and the wrench is 120 degrees? So let's figure that out. Okay, so this, again, is really simple to compute. We just change one thing. So the length of the wrench hasn't changed. The force applied hasn't changed. Just the angle has changed. So this is 1/2 times √3/2, which is the sine of 120 degrees. That gives us √3/4, and that's about 0.43. So as we can see, the torque is greater in this case. Of course, the max amount of torque would be, or would occur, that is, if the force is applied orthogonal to the wrench here. That would give us sine of pi/2, sine of 90 degrees, which would be 1, and would give us a torque of 1/2 joule. Hopefully you found this helpful. Please keep calm and math on.